In today's digital world, data is everywhere, from social media to health tracking. These aren't just static numbers, they are continuous flows. But how do we understand all this changing information? This is where calculus in action begins. Integrals help us accumulate small changes over time to form a final result. In data analysis, this means we can calculate totals, study trends, and discover hidden patterns in large datasets. In this video, we will explore how integrals are used in cumulative metrics, trend analysis, and pattern recognition in data streams. Let's dive into our first concept.
Let's start with the cumulative matrix. It is simply the grand total of everything that has been done from the start until the exact moment. For instance, total distance of jogging. Instead of manually counting every step, we use integral to handle the continuous flow of the movement. Mathematically, the definite integrals help us to compute the total accumulation under the curve. It is a shortcut to find the grand total of a flow. This formula, the integral of f of x from a to b, is like a timer. It adds every step of distance covered from the moment you hit start A until you hit stop B.
Next is trend analysis. Trends show how data changes over time, whether it increases, decreases, or stays stable. For instance, total sales of a store over time. Sales data isn't just a number, it's a story of whether the business is growing or failing, which is the heart of the trend analysis. Integrals help us understand the overall behavior of data, not just individual points. When we integrate a rate of change, we can find the total effect over time. This helps businesses and scientists to make predictions and decisions based on patterns instead of guesses. So integrals turns raw data into meaningful trends we can understand visually and mathematically. Basically, it turns clutter into clarity.
Lastly, integrals help us find patterns in data streams. For instance, heartbeat monitoring. On a screen, you often see tiny, shaky lines that don't really mean anything. These are just noises that can be distracting. The integral is a cleaning tool. It ignores the messy, fast distractions so you can see the steady, important truth underneath. It turns a shaky mess into clear information that saves lives. To conclude, integrals are not just mathematical formulas, they are powerful tools in data analysis. They help us calculate cumulative values, understand trends, and discover patterns in continuous data. Without integrals, large datasets would just be confusing numbers. With integrals, they become meaningful information we can use to make smarter decisions.